now you are able to see my screen.
Yes, sir. Yes, sir.
Is
Now
this
it
it?
is visible.
Yeah. Yeah. So if in between any disturbance is there, kindly inform me so that I'll be able to understand, because I am here only able to see the full screen.
Okay, sir.
So if anything in between, if you want to interact also, you can interact. So uh, we will start the discussion on this particular topic. As you all will be knowing that this fuzzy logic has been one of the industrial standards, and it has taken the attraction of uh, all the international experts because of the relevance and importance. As we go from the most important part of computational intelligence, we can see this fuzzy as one of the part. In the computational intelligence, there are three major parts. One, what we call as the learning capability, and without a learning capability, we cannot find a computational intelligence system. So this artificial neural network will provide you a learning capability. Similarly, you have something called representation capability that is also very much importantly needed for a computation intelligence system. For this representation capability, we have something called fuzzy logic. And the third important part of computational intelligence is the optimization capability that will be provided by evolutionary computation. So these three things together will make you a system as computationally intelligent. And instead of artificial neural network, you can have any machine learning techniques there. And instead of evolutionary computation, you can have any nature-inspired computing there for optimization capability. And similarly for representation capability, fuzzy logic is there, rough set is there, probability is there. There are uh, hybrids of all these things which can call as representation capability. And we want to really understand the need of the representation capability and the importance of fuzzy logic, because this talk entirely focuses on fuzzy inference system and its mathematics behind it. And for that, I will take you to some other slide which will help you to understand the importance of fuzzy logic. As you try to play something called badminton, right? The cork will be coming from the opposite side, and we will never be taking a protractor to measure the angle by which the cork is coming. We will never take a speedometer to measure the speed by which the cork is coming, but we will be having our bat, and within a fraction of a second the cork will be coming near to you. And what you will do, you will have a bat and you will apply a pressure. We human beings are doing that. How it is possible? Because you have a human eye as a sensor. Through this sensor, images are being captured. If you have a good sophisticated camera, you will have more than 14 images per second, 14 frames per second. Similarly, all the images, when it goes to a brain, it analyzes, it tries to do the calculation, it tries to find out the angle by which it is coming, it tries to find out the speed of the cork, it tries to find out the target where you want to place the cork. Everything, the calculation goes behind. And the control, there are two regions on the brain, one called control area, and the called sensory region. So the control region of your hand actually gives a control signal, so that you are able to you are able to position the bat accordingly. And also it gives a control signal to the hand, so that you will be able to apply a particular force. You want to apply a particular force, that because of that force only the cork will be moving. So you have to position the hand accordingly. For that, a control signal will be coming, and similarly you have to apply a force. For that also it will be coming. If the same thing if a system want to do, right? There are a lot of complexities available, right? So whenever you come to real life, you can experience that there are some uncertainties coming into picture. There are some ambiguities coming into picture. There are some vagueness coming into picture. So all these things we have to handle it properly. So here, certain times we will think that exact measurement of the angle and exact measurement of the speed will help. But more than that, brain is not exactly measuring, but rather than it is having something called approximate measuring, right? It is having some type of mechanisms to do there. Right? Even if you ask a robot to play a football, the same thing will happen. If you ask somebody to have sugar, right, you will never ask in terms of grams. For example, I want 5 grams of sugar or 3 grams of sugar or something like that. So there also human beings are having the habit of making something called approximate values, something like a person is tall rather than exactly measuring the thing using a meter. You will say he is tall, he is short, and certain words like small, big, large, right? So there are a lot of words that we use in between human beings. Based on that, only we are able to do something called calculations. That is how the brain actually thinks. So people started thinking that whether we will be able to do such type of calculations without using numerical values. That is where the starting of their fuzzy logic comes. Now, again, in depth of study, if you see that the need and necessity of fuzzy logic systems, in earlier days, we used to say that the data is being processed and we call data processing. And the computer is usually named as a data processing machine to convert data to information. Right? Later, when we thought that information is not sufficient for the human being and we want to process the information as it is, something called information processing, all the research part comes here. All the uncertainty comes here, vagueness comes here, ambiguity comes here, everything comes here. And it is very difficult to convert something called information to knowledge. A very good example that I would like to quote to you all is in this particular slide. Right, this slide here you can see that a big metallic stone is coming and falling on the top of this person, right? This person, and this person is trying to give the information about the stone, right? 1,500 kilogram mass is approaching your head at a speed of 45.3 meter per second. Very great information he is giving, exact numerical values. But that is not going to save because it is coming at very high speed. And definitely within, before I finish my talking about that particular information, the person will highly get affected. So what is happening that you have a high precision here, right? But this information with high precision is not going to help this common society or this particular person. So what we have to do, we have to move away from precision towards significance, right? We will be moving from precision towards significance. When you move away from precision towards significance, you will lose all the exact numerical values. Instead of 1,500 kilogram, I will say a huge mass is coming down. Instead of saying that 45.3 meter per second, I want to measure it also. That also will take some time. So instead of saying that 45.3 meter per second, I will say in terms of a word called high speed. So high, right? Huge mass, huge. Right? Some words I am substituting in there so that I am slightly moving away from precision towards significance, because I know that measuring those things and even computer, if it wants to measure it, the speed and all this, it takes some time, right? We want to avoid that. So you substitute some words there. So once you substitute the words, again it is not going to help. So you have something called move out, move back. With high emotion you will have. So just move back. If you say, the person will ask why I want to move back, right? Rather than you say that move back with high emotion. So that will help the person to understand that something is going to happen. There everything comes into picture. Ambiguity comes. Why the person is asking me to move back? Uncertainty, right? Vagueness. That something is going to happen. What is going to happen? Whether I want to move back, which side I want to move back, right? How fast I want to move back. Everything will be vague. Suddenly I have to act something. Because of that action that I am going to do within the fraction of a second, I will get escaped. Right? So certain times I will be looking in different direction when the person is asking me to move back. Then suddenly, whether I want to see his face, whether I want to listen his thing, so a lot of things comes. That is where we say that whenever in real life situations we have all type of uncertainty, vagueness, and ambiguity. Think about a case when you have MRI image of tumor of a brain. Certain portions you will have something called cancer. Certain cells will not be cancerous. Certain cells will be tumorous. Certain cells will not be tumorous. So the radiologist will be having. They will be sitting and they will be having arguments whether this is cancerous or not. So once you decide, you will mark it. Then only you will pass it to a doctor. So radiologist is the first person who discuss about the cells and the responsibility of whether it is cancerous or tumorous or something like that. So it means that there also ambiguity comes, whether this is cancerous or not. Sometimes you will have doubt, right? So they will 2 to 3 people when an emergency situation comes and the MRI is being taken, and 2 to 3 people will have a marking on that based on the discussions. So in real life situation, whenever you see it, you can see ambiguity everywhere, right? That is why we talk about uncertainty, vagueness, and ambiguity. Uncertainty is something that which can be split into linguistic type, stochastic type, informational type. Linguistic type, we talk about low, tall, young, and other words that we use normally. And stochastic type, depending upon the probability that you roll a dice, what will happen next, tossing a coin, what will happen next, whether it will be head or tail. And there are information related answers. You are brilliant, we say. You are brilliant, right? You are beautiful. So something like which is related to how much it is measurable, how much value we can give to it. It's not known. So those type of uncertainties are there in real life. We want to handle that properly. And if you see the vagueness, right, when you have a point here somewhere here, and we will be able to say clearly that whether this point is inside the circle or outside the circle, because the circumference of the circle is very, 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 very clear. And when we have a point somewhere here on the right side, right here, somewhere here, it is very difficult for us to say that whether it is inside the circle or outside the circle, because the circumference of the circle is not at all clear. The darkness slightly decreases, and it can go even up to infinity. There the vagueness comes. You have a number plate, because of the fog, because of the rain, I am not able to see the number plate. I feel that it is 1 or 7. I have ambiguity or vagueness. I still have vagueness that is 7 or 1, right? And similarly, when you see the picture that is on the bottom, you can see the fishes, right? So starting from bottom to top, here also there is a fish, but since the what is called as the circumference of the fish is not clear, I am not able to visualize it as a fish, but there was a fish here, right? Similarly, several number of fishes are there. From top to bottom, if you measure the number of birds, then also ambiguity will come, vagueness will come, right? So there are uncertainty, vagueness, and ambiguity in the picture that helps us to make us to think about the need and necessity of something called a representation capability, especially for the purpose of computational intelligence system. And there are several examples we would like to say. There are something called electronic noses, which will try to smell something called the smell of food items, right? So there we will be able to smell whether the meat is the fresh or it is 1 day old, right? There are small electronic noses, big electronic noses, because these are all electronic devices. They will provide signals, and these signals has to be interpreted properly. All these signals will be having uncertainty, ambiguity, and vagueness, right? Similarly, computer tongue is an electronic device, small electronic device. It is able to taste 1,000 different flavors developed by University of Texas. Still, it's an electronic device giving signals, and these signals has to be interpreted properly for that. So these things you have to keep in mind. And similar is a case for the smell printer, which will print the smell based on whatever you see on the screen. Right, the printer will open 1 or 2 jars. For example, it will be opening the smell of something called the pizza, and it will have a fan that will project the smell, so that you will feel that smell when you see something on the screen. Right, there comes the real need and necessity of fuzzy logic system for representing uncertainty, vagueness, and ambiguity. There are other representation capability, as I already mentioned to you about rough sets and other related probability theory and all these things. This fuzzy logic has having a different way of handling the uncertainty, ambiguity, and vagueness. That is why this fuzzy logic has become an industrial standard. So in the previous slides, I was trying to explain you the need and necessity of fuzzy logic system. And it is part, as I already explained to you, it is part of the computation intelligence, one of the three components, major components, that is learning capability, optimization capability, and representation capability of the computation intelligence system. Now we will see that when the fuzzy logic has attracted the world. In 1965, actually, Professor Sade came up with the suggestion of fuzzy sets, and he tried to publish in a journal. And after 20 years, in 1985, when the biggest application of industrial application of fuzzy logic, that is Sindate train system in Japan, when it made the world to understand the real importance of fuzzy logic. This train is able to move fast and stop at exact precision, and it is a driverless train. So because of the working and the efficiency of that particular train, people try to understand the importance of fuzzy logic. Uh, Up to then 20 years it took for the development of various years. If we can just go back and see the history, this is the father of fuzzy logic. This is the Professor Sade, and I was able to meet him long back in Hong Kong. And this is the person, Professor Sade. He came up with the proposal in 1965 regarding the fuzzy sets. See the history, a little bit history. 1965, the first paper, right? He's actually faculty in electrical engineering. Foundation of fuzzy set theory put forward in 1965. In 1970, Europe started to apply in control engineering, their first application of fuzzy logic in control engineering. In 1975, fuzzy logic has been introduced in Japan. In 1980, there was empirical verification of fuzzy logic in Europe. And 1985, that is the broad application, Sindai railway subsystem that happened in Japan, that is broad application of fuzzy logic. And 1990, Europe, there was a broad application. In 1995, in USA, there was a broad application of fuzzy logic. And in 2000, the fuzzy logic has become an industrial standard that can be used for each and every application, so that we will be able to handle the uncertainty, vagueness, and ambiguity in a better way. That is how the history behind that. And there are a lot of applications of fuzzy systems that even if you go through the Google and just give the application of fuzzy systems, you can see n number of fuzzy systems, right? Even control system, information system, pattern recognition, decision support, n number of places you can see. Even fuzzy cookers, right? Rice cookers, washing machines, camera, distance, the camera which is able to capture images from a long distance. Those type of cameras also comes with fuzzy logic chip embedded inside that. Now, slowly coming inside the mathematics behind fuzzy set, that is most important to understand. There are a lot of mathematical study in fuzzy sets. You can see fuzzy set theory books as like classical set theory. Fuzzy set theory also, a lot of books has been come. Even Sade has written several books on fuzzy sets. And as far as fuzzy inference system is concerned, there are a small part of the fuzzy set theory that is most important that we want to understand, so that we can clearly implement the mathematics behind the fuzzy inference system. So that we will slowly go into the classical logic, so that we will be able to understand how it is different from fuzzy set. So classical logic, we normally have if we have a variable x, and we create a characteristic function called mu, and that characteristic function will take the value 0 or 1, true or false, yes or no, presence of current, absence of current, something like that. Suppose you take an example, right? Suppose here in the x-axis, this is the place where we're having something called age 20, right? Suppose you want to represent a system where you want to check whether the person is young or not. A person is young if he is less than or equal to 20 years of age, and if he is more than 20 years, then he is not young. That is the system that you want to develop. So suppose if you use classical set theory, you have the variable called x, right? And you have the variable called x, and that x you will check whether it is something called um, less than or equal to 20, right? This is the condition. Even if you write a C program or any program, you will be writing something like this, right? If x less than or equal to 20, right? Then if you want to print it, right, or see out young. Otherwise, else you will write something called uh, what is called not young. So it means that there is, if this x has been passed through this uh, characteristic function, if it is less than or equal to 20, automatically it will give a value 1. If it is more than 20, it will give a value 0. It means that there is a sharp jumping, right? This is the portion where you say 1, and this is the portion you say it is 0, right? You from the 1, after whenever it becomes more than 20, it jumps towards what is called a 0. So there is a sudden jump from value 1 to 0. So you switch on a light and switch off a light, right? Normally, you are making the current as 0, right? So similarly here, suddenly from 1 to 0, is sharp jumping is there. That sharp jumping, Professor Sade does not want. He wants something else, right? Rather than jumping from there, he want to have something called a inclined way of doing. Rather than suddenly jumping, he want to slowly have a inclination there, right? That is where different scientists have come up with different ideas, like multi-valid logics are there, three-valid logic, yes, no, or maybe. Yes is 1, no is 0. In between there are one value, right? In between yes or no, there is something called maybe, may not be, something like, right? So those type of things will come. There are three valid logic. Similarly, multi-valid logic also, there several in between constraints will come, right? So here what Sade has done is, he, instead of a characteristic function, he created a membership function which will take the values in the closed interval 0, 1. Here it is a set, right? It is a set. Here is a closed interval starting from 0 to 1. And he said that you can create any type of membership function there. And based on the membership function that you have provided, it will give a value between 0 and 1, right? Either 0 or 1, or a value in between that. For example, a person with 23 years of age comes here. In the case of classical logic theory, what you say, the 23 will come somewhat here, right, in this position, 23. So what will happen? Automatically, you will say that that person is not young. But in the case of fuzzy set, what Sade has done is, you represent a membership function in this region, right? For example, it's a trapezoidal type function. And when a person with 23 years of age comes, it gives a grade, something like 0.8. Right? If is this portion is something called 20 years. So when it is less than 20 years, automatically you will get a 1 value. But if it is more than this 20 up to this particular point, right? Suppose this is 23, right? So you draw a vertical line and it will give a value from this membership function. This membership function, suppose, is giving 0.8. What we will say is that the person of 23 years of age belongs to young group with a membership grade of 0.8. Suppose you take another value, suppose it is 25. Assume that in this particular portion we have something called 25. A person with 25 years of age comes, we will draw a horizontal line here, and suppose this is assume that this is 0.2. We will say that the person with 25 years of age is still young with a membership grade of 0.2. Right? This is the way by which he tried to represent it. Similar to an example, if I will quote that a person with, suppose our passing mark is 40 and a student is getting 39 marks. We used to say that the student has failed. A person gets 38 marks. We used to say that the student has failed. Rather than saying like that, we would like to say that the student with 39 mark has passed with a membership grade up to 35. From 35 to 40, if you draw a inclined line, and we say that even a person with 35, 36, 37, 38, 39 is passed with certain grades. That is how we want to say, rather than saying that, simply saying that he is failed with 1 or 2 or 3 marks, right? We used to have something called uh, grace mark, giving grace mark for those who are getting 36 and above, and giving 3 marks and let him pass, something like similar to that. Here, instead of giving grace mark, he will be told as passed based on the grade also. So you fix membership function on certain regions. Based on that membership function grade, you can decide, right? That is how the fuzzy logic has evolved. And in order to represent the membership functions, there are various types of membership functions available. For example, triangular membership function as seen here, right? There will be a center portion which will have a value here, and you have a left end and a right end. Both will be having values, right? So based on that, you will be able to write a function, mathematical function for triangular membership function, right? For example, when you are between A and B, you have something called slanting line, right? For that, you have this equation, right? When you are between B and C, right, you have a reverse slanting line, right, where you have this C minus X divided by C minus B whenever you are in between, whenever X is in between B and C. Otherwise, it will be 0. So like that, any type of membership functions, you can create it, and each of the membership function will have a mathematical function. Normally, most of the toolbox comes with a function, so no need to remember it, by heart it. Because internally, when you call a triangular membership function, automatically it means that you are using a function, mathematical function. Similarly, if you see the trapezoidal, right, here you can see from B to B dash to C region, it is 1, right? It is taking a value 1. Right? So it means that at that region, you can see whenever the X is in between B dash less than or equal to X less than or equal to C dash, you have the value 1. Remaining, you have this landing from A dash to B dash. You can see there is a portion which is responsible for this function. And similarly, this landing region, right, from C dash to D dash, you have again something called uh, a slanting line. There also you can see the equation. So whenever you take any type of functions, right? For example, bell-shaped function, exponential e raised to minus x minus m square divided by s square, right? There's an exponential function, especially for bell-shaped functions. So similarly, each and every membership function internally, it will be represented as mathematical equations. Since you will have so many slanting positions, you will have so many equations governing that based on the conditions of the values. So when you say that a triangular function is fixed, for example, a triangular function is fixed, we want to know the value of A, we want to know the value of B, and we want to know the value of C. If we say that a bell-shaped function is fixed at a location called M, then this will be the center. And you also want to say the spread, right? There will be uh, what is called as variance of these things. We want to fix it. That is something called S, right? This standard deviation and variance you should know, so that we will be able to fix this bell-shaped function. So each and every membership function will have parameters. Those parameters you will know automatically when you fix certain membership function, certain locations, and depending upon the spread by which you are having, whether the triangular membership function is leftward, spread in the leftmost or rightmost. Depending upon that, you will have various values on the left side as well as on the right side, right? So that is the main thing that you want to understand when you think about what is called as membership functions. Now you think about various other types of membership functions available in what is called as fuzzy logic. You can have something called trapezoidal membership function, you have G-bell membership function, you have triangular membership function, Gaussian membership function, goes to MF, SMF, ZMF, P sigma MF, D sigma MF, Phi MF, Sig MF, like that. So all these membership functions will have its own functions. Even if you Google search, you will be able to find out the mathematical equations governing all these things, right? It means that if you say a membership function, automatically your mind should come that there is a mathematical equation governing that. So any value when you give to that function, automatically it will give a grade. For example, if you are fixing a trapezoidal membership function somewhat here, and your current value is somewhat coming here, then automatically it will give a grade something like this, right? When it touches this particular portion, right? So you define a function. Whenever you pass that particular value to that function, it will give a grade. That is how the function is being written. So you should remember that. And there are a lot of fuzzy set operations available. If you take any fuzzy set theory books, right? Any fuzzy set theory books, you can see a lot of logics. Like classical set theory, you have union, intersection, right? Uh, all these things. Similarly, here also you have all such type of things. But rather than going deeply into all other things, we want to implement fuzzy inference system. So whatever is needed for the fuzzy inference system, only we are going to discuss it during the remaining in this slide, right? So we will see union, right? Example, union in fuzzy union itself has been defined by multiple scientists. One of the scientists says that union can be defined in terms of maximum of the set containing mu a of x, comma mu b of x, right? So it says that if you want to take a union, you take the maximum of the set containing mu a of x, comma mu b of x. Similarly, another scientists have come up with an explanation telling that the union is nothing but a set of minimum of the set consisting of one and the summation of both these things, right? Mu a of x plus mu b of x. And similarly, when you see the intersection, right? When you see the intersection, one of the scientists says that it is the minimum of the set containing mu a of x, comma mu b of x. Another person has come up with the explanation that it is nothing but a product of mu a of x into mu b of x. So we will see a small visual thing, right? For example, this is the membership function A positioned here, and this is another membership function B positioned here, right? If we use this particular thing and try to find out the union, what will be the value? So the entire thing will become red. And similarly, if you use this minimum, what will be happen? That also we will see, right? So the entire here you have a gap here, these regions. Here you not have a gap, but the entire thing has become red. Similarly, in the case of intersection with this minimum, we will see that what will be the result of that minimum. And similarly, if you do the product, you can see the smallest portion, right? This is the smallest portion which is being highlighted. So depending upon the type of union and intersection operations that you are using, you will be able to understand that how you will be able to find out the maximum and the minimum, right? So there are other set operations also available. These are only two examples. One is called union operation, and another called intersection operation. And these union and intersection operations are very important as part of fuzzy inference system. That is what I am showing you. One more time, I will show you this thing so that you will be able to understand. So in the case of maximum, the red portion is going, which is highlighting is the union. And in the case of union using minimum, you can see this is a portion. In the case of intersection with minimum, you can see this is a portion which is you are getting. And in the case of intersection using product, you are able to see this is the highlighted region. So this is what you will be able to see based on what is called as union and intersection. Any doubts so far? You will be able to discuss it. 1 minute.
Hello. Hello, Rajesh sir.
Please wait 1 second. 1 second.
Okay, sir.
Yeah. Yeah. Yes. There was a small break. I don't know. Okay. You are able to hear me?
Yes, sir. We can hear
Yeah.
you.
Okay. Okay. You are able to see my screen?
Yeah.
Okay. Okay. So this is how the union and intersection operation works, and this is most important as part of fuzzy inference system, because you will be most of the time doing the union and intersection operations, especially when you handle the rules. So now coming to the other part of the fuzzy inference system, whenever you have a variable and you want to declare this variable as fuzzy variable, you want to do um, something called converting the temperature variable into fuzzy variable. If you want to convert into fuzzy variable, you want to represent it in terms of some membership functions. For example, if you have a temperature starting from 0 degree to 100 degree Celsius, you divide this into three regions. For example, cold region, warm region, and hot region. And in the cold region, you represent by some type of membership function, whatever you wish. And the warm region, you represent by some type of membership function. And in the hot region, you represent by some other membership function, right? The same membership function can be same, it can be different, and sometimes it depends upon the problem also. Now when the temperature is told, rather than saying that if I say the temperature is 80 degree Celsius, rather than saying 80 degree Celsius, I am interested to say that temperature is hot. If the temperature is assumed that it is 50 degrees Celsius, rather than saying the temperature is equal to 50 degrees Celsius, I would like to say temperature is equal to warm, right? So once you do this division of the entire region of the temperature and assign some membership functions and label it accordingly, now the temperature variable has become a linguistic variable or a fuzzy variable, which will be able to take the values like cold, warm, and hot rather than some numerical values. So what it means that you convert a variable into a fuzzy variable or linguistic variable, where the entire domain, right, domain of that particular variable, you have a domain for any variable. So that domain you will be dividing into different regions. Each of the regions you will be providing you a membership function, and that membership function will be labeled. There will be something called a label for that. So what we will do, we will say that temperature is equal to cold, temperature is equal to warm, or temperature is equal to hot, rather than temperature is equal to 80 degree or something. So all numerical value we will we will vanish here, and we will provide only in terms of what is called as linguistic terms or fuzzy sets. Right, this is the first step in fuzzifying any problem. Right, given any variable, you convert it into fuzzy variable. For that, you have to divide into regions. Each of the regions you have to provide membership functions. Membership function I already told, whenever you place it, automatically you will know the parameters of the membership function. You should also know the equation of the membership function that you are going to use. Right, that is very important. Now once you do this, right, so once you make this all the variables, whatever variables that you are having in terms of these labels, the next step is making rules. So you make rules of the form if antecedent then consequent of the path, right? Something called if antecedent then consequent. If temperature is cold, right, we are not putting any numerical value here. If oil is cheap, right, then heating is high. So this temperature is a fuzzy variable, oil is a fuzzy variable, heating is a fuzzy variable. Temperature is currently taking the value cold in this rule. Oil is currently taking the the label called cheap. The heating is taking the label high, right? Like that, you will be able to see here that the entire rule is in terms of if-then condition. So you have different input variables. All the input variables are fuzzy type, and which will be taking something called fuzzy labels rather than something called numerical value. So what here we means that we are entirely moving away from numerical world towards a fuzzy world, where we will not be able to see any numerical quantity whenever you write a equation, whenever you write a condition. write a rule. We are currently writing fuzzy rules. In that fuzzy rules, you will not be able to see anything, right? So, for example, you are driving a car, driverless car. Assume that driverless car is moving, and when a pedestrian is moving in front of you, your vehicle is moving very fast, and the distance of the pedestrian is very near. The pedestrian is very near to your vehicle. Then you have to apply a sudden brake. This is a rule. This is a fuzzy rule that no numerical quantity comes. Everywhere I use the word comes something called I am moving very fast. That very fast is something called a region of the speed, right? Similarly, the distance from the pedestrian to the vehicle. If it is very near, this is a region in the distance variable, right? At that region, you have a label and a membership function. That membership function you are pinpointing. So everywhere when you try to do or handle using fuzzy rules, you will not be able to see any type of numerical quantity there. You will be only able to see rules of this type, something called if-then rule, where all variables will be a fuzzy variable, and each fuzzy variable will be taking something called fuzzy sets or fuzzy labels as assignments. So it is very important to understand. Now you take an example, right? For example, you have two input variables. Assume that you have a temperature, and temperature you are dividing into three different parts, three different regions. One region you are naming it as cold, another region you are naming it as warm, and the third region you are naming it as hot. Similarly, there is another input variable called oil price, where you are dividing into three different regions. One region you are naming as cheap, another region you are naming it as normal, another region you are naming it as expensive. So two input variables, one called oil price, another temperature. Based on that, you can create something called rules. How many rules you can create? For example, temperature is having three labels, fuzzy labels, and oil price is having three labels. So 3 into 3, you will be able to make something called 9 labels. Means 9 rules you can create based on this. If the number of regions for each of these temperature and oil price are higher, for example, you have 5 regions for temperature: very cold, cold, warm, hot, very hot. Similarly, very cheap, cheap, normal, expensive, very expensive. So if you make five regions for each of these input variables, the total number of rules that you can create is 5 into 5, something called 25. Now the rules, how will you read? We will see, for example, this particular rule we will read, right? If the temperature is cold and the oil price is cheap, then the heating will be high, as heating is the output variable. Similarly, this rule, if you try to read it, we can read that if the temperature is hot and the heating is normal, then the oil price is normal, then the heating will be low, something like that. So this is how you will be able to make rules. So depending upon the number of regions or number of sets, fuzzy sets available in each of the input fuzzy variables, the number of rules will increase. If you have more number of variables for each of the variables, if you have more number of regions or fuzzy regions defined, then the number of rules will increase. Right? This thing is very importantly, you should understand how we will mathematically write a rule, fuzzy rule based on the fuzzy variables. Right? So in their fuzzy inference system, if you look inside, there are four components available. One called the fuzzifier. The fuzzifier is the part where you convert all the numerical values into fuzzy values, fuzzy labels or fuzzy sets. Right? All the numerical values automatically it will be converted to fuzzy. And defuzzifier is the part where what will happen is all the non-numerical values will become numerical. So once you fuzzify it, the fuzzy values will come here. There will be set of rules. We call it as inference engine, right? This inference engine, by taking the rules available in the rule base, it will make a decision. Assume that you have two different judges making two different decisions, and finally you have to consolidate three different judges for seeing a drama, and they make a judgment, and finally you consolidate and rank it. Similarly, you will have different type of rules. Each of the rules will fire certain answer, and that answer will finally convert it to make a decision. That decision, whatever decision that is coming here, again it will be linguistic of type. You have to convert into numerical value. For that, you need a defuzzifier that converts the non-numerical value or fuzzy value into a numerical value. so that you can directly apply to any system. That is how the entire fuzzy inference system works. Better way of visualization, I will explain it here using this slide. If you see that I am drawing a horizontal line, right? This horizontal line is nothing but the region below this horizontal line. You can see white dotted line, right? So below this line we call the numerical level, right? Above the horizontal line we call the linguistic level. So this plant, assume that this plant is any plant. Assume that it's a nuclear reactor where a lot of collisions happens. When the number of collision increase, what will you do? You automatically insert the lead rod. When lead rod is inserted, it will attract or capture most of the neurons. So the number of collisions will come down. So that is what you want to do. So when the number of collision increases, you will have certain sensors inside that. It will measure the number of collisions. That will give something called numerical values. Those numerical values says that the number of collisions is high. So whatever sensors that you have placed inside, that sensors will give a numerical value, measurable value. Thus, measurable value, we do the fussification step. Once you do the fussification step, then their collision numerical value will convert into something called linguistic value or fuzzy value. For example, you say that number of collisions in terms of some numerical. So you say whether it is high number of collision, low number of collision, or medium collisions. So you convert like that. So fussification is the step by which you convert all the numerical values that you receive into something called fuzzy values. So once you get this measured linguistic values or fuzzy values, you have a fuzzy inference, as I have explained earlier, which will have a set of rules. Those rules will get activated and it will fire certain answers. And based on the consolidate of that thing, for example, you want to apply a sudden brake. Your car is moving very fast. You are very near to the pedestrian. You want to apply a sudden brake. So your command variable will be sudden brake, right? If it is a nuclear reactor, I am saying more collisions are there. Your command variable is something like insert more quantity of lead rod inside. So that is again something called a linguistic value. It is not a numerical value. So you have to convert into something called a voltage applicable to a motor, so that the motor can act it and push the lead rod inside the nuclear reactor. Something like that, right? So there, this command linguistic value, whatever that you have given as a got as output from the fuzzy inference system, you want to defussify it, and that once you defussify it, you will get a numerical value that can be in terms of voltage, in terms of pressure, in terms of something else that is needed for the plant. The plant can be anything. It can be a forecasting system, it can be a tsunami prediction system, it can be cancer identification system, it can be driverless car, whatever may be the thing, right? This is how the entire fuzzy inference system works. So at a nutshell, you have to understand that there is a fussification which will convert all the numerical value into non-numerical value. There is a defussification which will convert all the non-numerical value into numerical value. So this is the thing that is happening. In between that, you have a fuzzy inference or inference engine that will have a set of fuzzy rules. Each of the rule will be of the type if then condition type, right? And each of the variable that you are having will have a set of membership functions. Membership functions are defined in terms of mathematical equations, as you have already seen, right? Now, how the firing will happen? You will see certain examples so that you will be able to clearly understand it. See, for example, you have two rules, right? For one, each of the rule having two input variables. For that, you have defined a location for the fuzzy labeling, right? For example, for the variable x, right, you have placed a membership function here in this region, and it is named as a, right? Similarly, for the this is a current value. Whatever this line is showing is the current value of x. For the current value of x, you will getting a grade somewhere here, right? In this particular region. And similarly, you have another variable called y. In that y, there will be different regions. And for this particular rule, we have selected this particular region, and this region is having a membership function which is represented by b, right? For the variable y. And for the current y value, right? For the current y value, suppose the y value is somewhat here, you will get something called a grade somewhat here, right? In this region, right? And you have if you have something called a rule which is having set of input membership functions. Similarly, you have something called output variable with a membership function, right? So I have told the minimum, union, and all these things I have mentioned, right? So here the inference is something called max min inference. So you will be taking something called minimum here. Certain mechanisms you can take even product here, right? Depending upon the thing, whatever you want to make it, min max, max min, product min, whatever the way that you want to make it, right? So the consequent part, if you see it, you can see that there is a membership function for the variable is set, and it is being positioned somewhat here, right? For this minimum value, whatever we are getting, the minimum of this grade from the variable x, the minimum of this grade from the variable y, you take the minimum and then try to fire it. You will get something called a area. That is the result that is being predicted by this particular rule. And you similarly take the second rule. The second rule for the same x variable, the membership function is in a different position. You can see the membership function in a different position. And the label is also different, see. And for the same x value, right, the same x value, if you draw it vertically, you can see it will take a different grade. The grade will be different, right? Similarly, for the y value, right, you have a membership function placed in a different position. And for the same y value, right, the same y value, you can see the same y value, it is giving a different grade. And this rule is also having a consequent where the membership function of the consequent part of the result part, right, that is also placed in a different location, and it is named as h. And once you take the inference from this particular rule, you can see that the firing will be in a different style. So these things we call it as consequent firings of each of the rules. This is only two rule case. Several rules can be there. Each of the rules will fire like this. All these things are complex regions, and these regions you have to consolidate together to form the consolidate output. And from this consolidate output, you want to find out something called the centroid or some other mechanism to convert the consolidated area into numerical value. That is what is called as defuzzification. So in the defuzzification part, you will find a centroid of this area, and that particular value will be coming as output of the fuzzy inference system as numerical value after defuzzification, right? So in the case of this is something called there are different types of fuzzy rules. One called Mamdani type of rule. A scientist called Mamdani has come up with a mechanism to make fuzzy rules where the consequent will be of membership functions, right? This is the consequent part where we are having then part. Then part we call it as consequent part, right? So we'll have membership functions, but there is another scientist called Tagagi and Sugino who came up with a mechanism of having something called a linear combination of the input variable as the output. That is called Tagagi-Sugino fuzzy inference system. So here, since the output value is in terms of the linear combination of the input variables, the defuzzification part is very, very simple here. Earlier case, since it's a complex area, the defuzzification becomes very difficult. But here, the defuzzification is very, very easy. Right? So you have an antecedent part like x is taking the set A1 and y is taking the set B1. And similarly, the second rule says x is taking A2 and y is taking B2. Then you have two different set values. Here you have some parameters called P1, Q1, and R1. Here we have something called P2, Q2, and R2. So this is how the Tagagi-Sugino rules are being made. So defuzzification is very simple. For example, the first rule will be like this. The second rule will be giving like this, and you take the weighted sum W1. So this weight W1 into Z1 plus this W2 into Z2 divided by W1 plus W2. So that much simpler will be the thing that when you see something called Tagagi-Sugino fuzzy inference. Now, before moving to any other thing, I would like to show you the MATLAB example so that you will be able to understand it very clearly. I think you are able to see my screen. Are you able to see my screen? Yes.
Yes, sir.
Yeah, okay. So this is a MATLAB which I am going to show you an example how to create a fuzzy inference system. So I am just typing fuzzy here. There are fuzzy GUI available by which you will be able to create fuzzy rules. So just type it fuzzy. You will get a fuzzy GUI where you have input variables as well as output variables. We will take an example of a doctor. We want to make a doctor who will be able to prescribe something called paracetamol. And the input variables will be something called temperature in Fahrenheit, and something called cold, how much cold you are having. And the output will be the gram, how much gram of paracetamol you want to eat, how much gram of paracetamol that you want to eat. So let us see that we want to have two input variables. So currently only one input variable is available here. There is an option to add. You click on edit. Once you click on edit, you have an add variable. And once you click on the add variable, you have an option called input, right? So everybody, I think you are able to see it. Inside edit, there is something called add variable. And inside add variable, you are having something called input. You click on that particular input, automatically you will be able to see that you have two input variables here, right? First one here and second one here, and we can name it. For example, you click on the first input variable. Here you can see the name of the current variable. You can change the name of the current variable as temperature. So automatically, when you click somewhere else, automatically you can see that the temperature will come on the bottom of the first input variable. The second input variable, I am going to name it. You just click it, and if you change the name as cold and click somewhere else, automatically you will be able to see that the second input variable, the name has been changed as cold. The output variable, that whatever you are having, you click it there and change the name as paracetamol, for example, PAR, and click somewhere else, you'll be able to see that the paracetamol has been appeared on the bottom of that particular variable. Now it is our duty to create regions, right, and assign membership functions for each of these regions. So you just double click on the temperature. You will get another screen where membership functions you can create. Default, you can see 3 membership functions. You can delete these default membership functions. For example, you just click delete, click on this and press delete, click on this and press delete. So you can see the domain from 0 to 1. But in case of temperature in terms of Fahrenheit, we want in terms of 99 to 104. So change the range. You can see the range where I am going to give the value as 99, and instead of 1, I am going to give 104. So once I click somewhere, automatically you will be able to see that the range and display range has automatically changes 99 to 104 Fahrenheit. Now I am going to add and I want to make regions. How many regions I want to make? So you click on edit. There you can see add membership function. Click on edit, you can see add membership function. So once you click on this add membership function, you will be able to see another screen, right? This screen shows that what are the types of membership functions you want to use. You can use triangular membership function, you can use trapezoidal membership function, Gaussian membership function, anything. Assume that we are going to click on this triangular membership function, and number of membership functions, number of regions you want to create from 99 to 104. How many regions I want to create? Suppose I want to say low temperature, medium temperature, high temperature. That is, suppose I want only 3 regions. You can click on 3. Suppose you want to say very low temperature, medium temperature, high temperature, very high temperature. Then you can click on 5. Like that, you can create any number of regions. Suppose if I create 5 and press OK, you can see that there are 5 membership functions coming here. All are triangular type. And if you click on this first membership function, you can change the name, very low, VL. And you can click on the second membership function. If you want to change the name as low, you can press on L. Here you can change the name of the label so that it is easy for you to understand it. And the third membership function, you want to say it is medium temperature M. And the fourth membership function, you click it and then change the thing as high. And the fifth membership function, you click it and make it as very high. So you can see that all the labels we have changed as very low temperature, medium temperature, high temperature, and very high temperature. Now, similarly, we can have cold also, right? In the case of cold, the default, there are three membership functions. I can delete it by just clicking on it and pressing the delete button. Now, I just want to insert only two membership functions, very low cold and high cold, right? Something like that. You can have any number of membership functions. Suppose I say that I want only two membership functions. Click on add membership functions. If you want triangular, you can press triangular. You can say two membership functions. Click OK, right? Automatically, you will be able to see two membership functions in terms of cold. The first membership function starts from here to here. The second membership function starts from here to here. So this I will name it as low cold, right? Low cold. And this is called high cold. So cold is very high and cold is very low. Now we have divided the input variables into regions. And for each of the regions, we have assigned the membership functions. And all these things has been defined. For temperature, we have assigned 5 regions. Each of the 5 regions, we have assigned membership functions. The cold, we have decided in the 2 regions. Each of the regions, we have given membership functions. Now going to paracetamol. Paracetamol, normally we have starting from 0 paracetamol to say $650, or even up to 750 grams of dollar we can think about. So you can give the values from 0 to 750, right? Automatically, when you click it and assign some membership functions, you will be able to see the changes here, right? So I am going to add membership functions. So there I am going to have, say, assume five or 7 membership functions in this paracetamol. For example, this middle one is the medium paracetamol, right? And this one low paracetamol. This is very low paracetamol, and this is very low paracetamol. Right. Similarly, this side, if you go there, here I am clicking it, I am telling that is high paracetamol. This is very high paracetamol, and this one I am clicking it and changing it as very high paracetamol. Right. So now you can see that I have assigned 7 membership functions. They were into 7 regions. Each of the regions I have assigned membership functions, and then we have created all the region splitting. We have assigned the membership function. We have positioned the membership functions. Now what we call as all the variables are now fuzzy. Temperature is fuzzy, cold is fuzzy, paracetamol is fuzzy. Now we want to create fuzzy rules. The next step is to create fuzzy rules. Click on edit. Click on edit. Then you have something called rules here, right? You can clearly see that there is a rules. Click on edit. You can see something called rules there. You click on rules, right? Once you click on these rules, you will be able to see a different new window which is coming up, where you can see if temperature is on the bottom. On the bottom, you can see all the labels: very low, medium, high, very high. Similarly, below the cold, you can see low and high labels that you have given. Similarly, then part on the right side, you can see the paracetamol, very low, high, medium. So now where numerical quantity appears, right? Everywhere we are having something called region only. So first you select low if temperature is low, cold is low, your paracetamol is very low. You click it and then add rule. There is an add rule button. Once you add the rule, on the top you can see a rule that is coming. If temperature is low and cold is low, then paracetamol is very low. Similarly, I am going to add a very high, right? If temperature is very high, click it. If cold is very high, then your paracetamol is very high. Click it, all the 3 things, and then add rule. Automatically, you can see that the second rule is been added, which is temperature is very high, cold is high, and paracetamol is very high. And similarly, I'm going to have something called very high temperature and cold is low. then I am going to have something called very high paracetamol, add a rule. Similarly, have a high temperature and a high cold. You are going to have very high paracetamol. High temperature and low cold, you are going to have something called high paracetamol. And we are having something called medium temperature and high cold. You are having something called uh, high paracetamol. Medium temperature and low cold, you are going to have medium paracetamol. Like that, you can add rules like that. Since we are having 5 membership function for temperature and 2 for cold, you can create up to 10 rules. Right? These rules, how it will look like. You can click on view. There are 2 things, rules and surfaces. We click on view. There is something called rules. So you select the rules. And if you try to click on that particular rules, you will be able to visually see the rules also. Right? This is how the visual rules will look like. So now you can drag this, right? I am dragging this and making the temperature as 100 degree Fahrenheit. And I'm going to say that my cold is somewhere here, right? Right? And you can see the paracetamol on the top, 365 grams of paracetamol. Right? Each rule fires something. And if I make the temperature is very high, it's very high, right? You can see the paracetamol changes. It has become 678 grams of paracetamol. If cold is also very high, assume that cold also very high, you can see 711 grams of paracetamol. If the cold becomes very low, right? You can see here the paracetamol becomes 625 and the temperature also becomes 99 degree Fahrenheit, very low. You can see the paracetamol is 375 grams. So this is how we can design something called fuzzy inference system. This fuzzy inference system is not optimal because we have manually fixed the membership function, and this membership function has to be tuned, has to be optimized based on some machine learning mechanism or nature-inspired algorithms based on some known data available from the doctors. Once you do that optimization, this fuzzy inference system will become optimal so that it can automatically predict how much gram of paracetamol you want to eat rather than eating the entire tablet. I hope that with these few things, I have clearly explained you the mechanism by which, the mathematics by which the fuzzy inference system works. I have also given a certain example of making a automatic doctor for predicting the paracetamol quantity. Now it is open for questions so that any doubt that you are having, you will be able to get it from me. Anybody is having doubts?
Dear participants, if you have any questions, you can unmute your mic and please ask, or you can post your queries in the chat box.
Sir, good afternoon, sir.
Yes, you can continue.
Sir, I am Sivakumar, sir, from Tamil Nadu.
Yeah.
Sir, I have one doubt. Sir, what is fuzzy number, sir? I mean, this is fuzzy set means the membership values lies in between 0 and 1, sir.
Yeah, you want to understand what is membership function you are asking, right?
Yes or no, sir? Fuzzy number, sir. Fuzzy number.
Fuzzy member.
Yes, sir.
Fuzzy number.
Yes, sir.
Fuzzy member or fuzzy number?
Fuzzy number, sir. Number. N-U-M-B.
Okay.
Yes, sir.
Fuzzy number means there are, I already told you that there are
Yes, sir.
lot of research that has been happened on part of fuzzy set theory, in which all the aspects regarding the fuzzy set has been come out. So even if you say a fuzzy number, that number will represent a region, right? Like labeling, that we are labeling.
Okay, okay, sir. Yes, sir.
It's
Yes, sir.
region,
Labeling.
right?
Yes, sir. Yes, sir. Yes, sir. Okay, sir.
ആരെങ്കിലും ചോദിക്കാൻ നോക്കണം.
Okay, okay, sir. Thank you, sir.
Any more queries, please? Okay, let's wind up the session. Thank you, Dr. Rajesh sir, for giving a good session on the mathematical foundations of fuzzy inference systems. Let me welcome the FDP coordinator, Dr. Anil AR, for delivering the vote of thanks.
Good afternoon, sir.
Yeah, sir. Before winding up, I'm very thankful to all the participants, all our faculty members. I know that those who want to have more such type of sections and more such type of collaborations, don't hesitate to contact me. I will be available in Central University of Kerala to provide all such type of extension activities. And thank you once again to Dr. Anil and other colleagues for inviting me, for providing this opportunity to give a wonderful talk on facility.
Good afternoon, sir. Rajesh sir. Thanks, Rajesh sir, because he agreed to participate our ADAL FTP as a resource person, and he covered the mathematical concept of fuzzy logic systems, fuzzy set operations, and fuzzy rules, and he implemented all these concepts in mathematics. Thank you, sir, for your wonderful session, and thank you all the participants for your kind cooperation for conducting this. Thank you all. Thank you all.
ഞാൻ സ്കിറ്റ് ചെയ്തോട്ടെ?
Okay, okay, sir. Okay, sir. Okay.
Thank you.
Thank you all the participants. So today's session, we came to the end of the session. Tomorrow, we are continuing our second day of FDP sharp at 9:30 a.m. Today's complete session will be handled by Professor Sumod Sundar on the topic machine learning using Python. So all the candidates may please join tomorrow sharp at 9:30 a.m. in the same Google Meet link. Thank you all.
Okay, thank you, madam.